So hello all, today we'll be discussing the topic on substation, and the contents for the following PPT will be: introduction to substation, classification of substation, comparison between indoor and outdoor substation, transformer substation, and lastly we'll be ending it with pole mounted substation. And as you all know that I have shared some of the study material along with you, so I believe that you have gone through that some of them and you know little bit about the performance of a transmission line. So as you have studied there, so we used to bifurcate our transmission line in three types: short, medium and long, depending upon the product of line length and frequency. Basically, when we will be transferring our power from generating substation to consumer end or load end, we will be having a substation in between to switch on the, or you can say to change the voltages or to change the frequency or to control the voltage parameter. For that, it is being very much needed in electrical engineering of substation. So as you can see in the PPT, a substation is nothing but the assembly of apparatus used to change some characteristics of electric supply. What all the some characteristics? Example, you can say it is voltage. We can change our current from AC current to DC current. We can also switch frequency, and we can also enhance the power factor, because as you know that the total transformer transmission line is nothing but the inductive line. So power factor will be quite low, and the load will be also inductive, as you know that the total load will be nothing, 80% of the load is nothing but the inductive, so power factor will be poor. So there will be certain types of substation available in which we can correct the power factor also. The most important thing in the erection of any substation is that it should be located at a proper site. At a proper site, we can say that it should be at the center of the gravity of load. What is meant by the center of gravity of a load? It is nothing but it should be at the middle of a particular city, so that the transmission line wires needed to connect the consumers or the nearest substation should be low. So it should be easily accessible, and it should be nearest at the load center. It is not so as the generating substation you have studied that it should be far enough from the load centers, but in the substation, when we are talking about the consumer at substation or the lowest substation, it should be at the center of the gravity of load, so that it can be easily operated and maintained. So the next slide, as you can see, that we have to start with the classification of a substation. In the classification of a substation, it can be most importantly be classified in two ways, that is the service requirement and the constructional features. So now first of all, what is service requirement and what is the constructional features? As the name suggests, as you can all see, that in the service requirement, it is nothing that how your substation will going to service, whether it will be changing the voltage, whether it will be changing the frequency, whether it will be changing the AC supply to DC supply and all. And as you can see in the constructional features, how it can be made, what will be the difference in the constructions of a different substation, that we have to see in these two classification, that is service requirement and constructional features. So the most importantly, according to service requirement, there are different types of substation available, that is you can see a transformer substation, switching substation, power factor correction substation, frequency changer substation, converting substation and industrial substation. We can go for all these substation one by one. So first of all, first is the transformer substation. Transformer substation is nothing, as the name suggests, it is having a transformer. So we can say that in this type of substation the voltage levels will be changing. Either we can say if the line is coming for at 132 kV, it will be step down, or it can be step up to some other voltage level. So the basic function of a transformer substation is the changing in the voltage level. In the switching substation, the second one is the switching substation. In that substation, the voltage level will not be changing. The voltage level will be constant, but only there will be switching of the power lines. The switching of the power lines means the voltage level will be constant. We can say that the power of the switching of a different power lines will be switched, or you can say the transposition can be done at these substations, because as we have already studied in the transposition part in transmission parameters, that transposition is always used to take place in a substation only. It will not be in the middle of the particular transmission line when we are laying it down. So we can say that at the switching substation the power lines are switched, but the voltage level will be constant. The most important part will be the voltage level will be constant in the switching substation. Next is the power factor correction substation. Simply you can say that as the name suggests, there will be power factor correctors. For the power factor correction, I have already shared some of the study material by the Oza sir. You can, if you have ever undergone that particular study material, you have already know that for the power factor correction, what we used to need, nothing but the capacitor banks, because capacitor will be the best part for the correction of a power factor. In the frequency changes substation, we will be changing the frequency. The best way that I can say is nothing but we are changing AC supply to DC supply, because in AC supply we will be having 50 Hz or 60 Hz depending upon the countries, and in DC supply the frequency will be 0. So in the frequency changes substation, we will be changing the frequency from any 50 Hz supply to or 60 Hz supply to 0 Hz. That is nothing but the AC to DC. So in frequency changes substation, will be changing the frequency, or either you can say we will be changing the supply from alternating current to direct current. In converting substation also, we can say that we will be converting our supplies. The converters will be available. You can say that when we are having a HVDC line, so there will be a converter substations. In that converter substation, there will be inverters in one part, and in the other part there will be rectifiers. Why we need inverters? Because at the inverter we will be changing the AC supply to DC supply, and at the rectifier end we will be again in inverter will be changing from DC to AC, and in rectifier end will be changing from AC to DC. So when we will be using the rectification, by rectification we can lay down HVDC line. Then the most important question coming in my mind, and it should also come in your mind also, why we need HVDC lines? HVDC lines is being needed because it will be operated at 0 Hz, the basic funda. As it is operating on 0 Hz, so we can say when we have to connect those parts of India in which they are operating at different frequency, so two different frequency parts or two different frequency areas cannot be added or cannot be synchronized. So for that, if we are having that kind of line which is operating at 0 Hz, then we can connect those two areas. So for that, we will be always having a HVDC line, high voltage direct current line, in which the frequency will be 0, and that can be used for the connection of these two or synchronization of these two areas. So for that purposes only HVDC line came into picture, came into prototype, and it is being now prevailing in a very good manner. So this is all you can say the part of a converting substation. In industrial substation, you can say every industry will be having a substation. As you already know that in Nirma University also we are having a substation of around 11 to 33 kV. So these big universities or these big companies is having a particular substation, and those substation will be used for the supply of those universities only. So that is a very localized substation, and that will be only around, you can say it can be of 11 kV, it can be of 33 kV, it can be of 6.6 kV also, depending upon the requirement of a particular substation. Okay, now coming to the next slide. According to the constructional features, there are different types of substation available. As you can see in the slide, the different types of substation are nothing but indoor substation, outdoor substation, underground substation, and you can say that it is nothing but the pole mounted substation. So in the as the name suggests, the indoor substation. So indoor substation are those substation in which are built indoor, which will not be available outside. So the limit for this kind of substation will be nothing but it will be up to 11 kV. For indoor substation, I again repeat that the limit for the supply voltage will be limited to 11 kV only. Above 11 kV will be having the outdoor substations, because above 11 kV the size of the equipments will going to increase. So to accommodate high level, high ranges equipments in indoor substation will not be possible. So outdoor substations will be available. But in India, high voltage indoor substations are also coming into picture, are also available. So it is, you can say it is again on the recent trends of a part in which indoor substations are also available with high ranges of voltage. It is nothing in the indoor substation. We can also say that it is of also type of a gas insulated substation. So GIS is also another name of indoor substation. AIS, that is air insulated substation, will be the outdoor substation. So you can say the insulation part or the insulation structure given in the indoor substation will be by the gas, and that gas is nothing but the sulfur hexafluoride gas will be used. That is very good insulator and that is having a very good insulating medium. And in the outdoor substation, air will be utilized for giving the insulating medium. Okay. In the underground substation, we can say when we are having a very highly populated area, very congested area, in those areas will be moving towards the underground substations. That is very less available across the world, we can say, or across the India, but it is also one of the possibility of having a underground substation too, where we can build where we are having very congested area or very highly populated or dense area available according to a or across the center of gravity of a load. Pole mounted substation is very simple, and you already know all this term, that is pole mounted substation. You already seen this type of substation. It is nothing but it is a transformer that is situated outside your home or house, which is giving you a supply of 415 volts 3 phase, and respective phases will be going to a particular locality having 230 volts 50 hertz. So it will be taking an input of 11 kV, it will be stepping it down to 415 volts 3 phase, and those 3 phase respective phases will be going to respective localities, and each phase will be having a voltage of 220 to 230 volts single phase. Okay, so pole mounted substation is the last end of a substation, we can say, in which we are getting from that only. After the pole mounted substation only we will be getting the supply at our home through a service mains. So pole mounted substation is the last substation. So in the next slide I am going to show you the structure, or you can say the schematic diagram of a pole mounted substation, which you can see, as I have already told you, that input will be the 11 kV. As you can see in the upper hand, there is an 11 kV overhead line through which a lightning arrestor is connected. It is an equipment that will be used to shut down the high voltage if it is appearing across a particular overhead line due to lightning. So it will going to give the path to the current when only when there is a high voltage. That is the function of a lightning arrestor. It will be showing the open circuit for all 50 hertz or for low voltage supply or for the regular voltage supply, that is 11 kV. But whenever there will be a high voltage, then lightning arrestor will going to come into picture, and it will going to give the path to that current, and it will be all shunted down through this lightning arrestor to the ground, so that all the other parts of a transformer will be protected. So every transformer should be, or every transmission line there will be a lightning arrestor, because lightning arrestor is the very, you can say, is the very important equipment in a particular substation. Through that, you can say the next equipment that is coming is fuse, that you already know, is fuse is always connected to protect a pole mounted transformer. And this one question is also asked in your class test also, in which you have to say that DO fuse, the answer will be the DO fuse, that normal transformers are protected, or you can say pole mounted transformers are connected or protected with a DO fuse, that is nothing but this fuse. And then there will be an isolating switch, and then there will be a transformer. In the lower, you can say secondary side, we can say that when we are getting a 415 volts or 400 volts, there will we are having the LT, that is low tension oil circuit breaker. So now the big question coming in my mind, and that should also come in your mind, that in the primary side we are having a fuse as a protective device, and in the secondary side we are having the LT OCB as a protective device. Why it is so? The reason is that in the primary side the voltage will be high. As you already know that power is constant, that is V into I is constant. So let's suppose, as in the input side you can see it is connected with the 11 kV overhead line. So power is high, voltage is high. As voltage is high, so current will be low. If current will be low, so it can be protected through a fuse. But now, as you can see in the secondary side, we are stepping down the voltage from 11 kV to 415 volts. So now we can say that as we are stepping down the voltage, power is again constant, and power formula is nothing but V into I only, and we are stepping down the voltage from 11 kV to 400 or 415 three-phase volts. So we can say the current will be start increasing. So as current will be high, so for that protection we will be needing a low tension oil circuit breaker. So for high, if we are having the high rated current, we will be having circuit breakers will be coming into picture for the protection. And if rated current is low, we can also use fuse to protect a particular device. So that is the reason that we are having in the primary side, we are having the fuse where we are having the 11 kV line connected, and when we are stepping it down to 415 volts, we will be having low tension oil circuit breaker to protect a particular pole mounted transformer. Okay, the last slide that we are coming into picture, that is nothing but the comparison between the indoor substation and outdoor substation. As you can easily see that indoor substation will be comprised in a particular room or indoor, so it will be requiring less space. Outdoor station will be requiring more space, because as we already discussed that in the indoor substation the insulating medium will be the SF6 gas. So all the equipments will be very nearer to each other, because we will be having the gas to insulate it. But in the outdoor substation more space will be required, because all the equipments will be situated at a very large amount, or you can say a sufficient amount of distance, because air will be there for the insulation. So again we can say the second point we want to discuss. So if we are having the fault location, so locating a fault in an indoor substation will be easy, because all the equipments are very nearer to each other. But in outdoor substation it will be quite complex, because equipments are really far. So if we want to locate a fault, it will be quite tough, because the area will be large. But as all the equipments are connected very nearer to each other, so there will be a high chances of fault escalation in a indoor substation. But in outdoor substation it will be a very lesser chances to escalate a particular fault occurred at a particular location. So it is very easy to understand that if the equipments are very closely packed or very closely situated, so we can say that fault can be escalated very easily in the indoor substation. But in the outdoor substation the fault cannot be escalated easily, because there is a respectable amount of distance available in a particular equipments of a substation. Because as we already discussed that the insulating medium required for that substation will be nothing but the air. Okay, so it is a very small video of a substation, and it will, I think, is covering almost all the topics of a substation. That will be very good for your, very good from the exam point of view. I will be sharing the next lecture on the bus bar schemes. That will be also very good for your exam point of view. So be vigilant, be always try to refer the study materials that I am sharing, and prepare well. No issues in that. If you are having any kind of doubt, I have already shared that Excel sheet in which you can write your doubts, or you can also mail me your required doubt. We are always available here to help you out only. So don't think and don't rush and don't panic. Any data, any material you want, you can always mail me, and I will be providing you the data. This is all for this lecture. Thank you.